Hello students, welcome to another video. This is Hamza Noor from Aero Education Network, and in this particular video I'm going to discuss a past paper question for International A-Level Edexcel P2 Pure Mathematics 2. The topic is particularly equation of circle, coordinate geometry, and here we have a past paper question which is June 2024, question number 7. So the question says that the circle C1 has equation in an expanded form, which is given as x square plus y square plus 8x minus 10y is equals to 29. The requirement of part A, part 1 is to find the coordinates of the center of the circle C1. Okay, C1 is basically the circle. And then in part 2, it says that find the exact value of the radius of C1. So first thing first, I'm going to convert this expanded form into a completing square form. And for that purpose, I have first rearranged the equation of the circle in this way that the terms in x are together, the terms in y are together, and the constant term is on the other side of the equation. Okay, so it's already over there. So what I'm trying to say is that if the constant is over here on the left hand side, you just send it towards the other side of the equation. Okay, so the terms in x are together. So first you observe this x square plus 8x. Okay, and then you apply the formula of the completing square form. Okay, as I've discussed in my earlier videos as well, we have a formula for completing square form which we are studying since P1. Okay, basically if you have an expanded form of a quadratic expression ax square plus bx plus c. So in order to convert this into a completing square form, you have this formula a times x plus b over 2a whole square plus 4ac minus b square divided by 4a. And if you have any other variable apart from x, let's say you have y. So a times y square plus by plus c. So in place of x, you just write y in this formula. Okay. So this is basically the formula which I use consistently throughout for completing square. Okay. So here basically x square plus 8x is converted into a completing square form where a is 1, b is 8, and c is equal to 0. Okay, so I've just used the formula. And the same formula I've used on y square minus 10y. Okay, because the variable is now y instead of x. Okay, so I have used the formula over here as well. And this whole thing is equal to 29. And then I'm going to evaluate the terms over here, 4ac minus b square over 4a. And I'm going to simplify b over 2a as well. Okay, so this gives you x plus 4 whole square minus 16 plus y minus 5 whole square minus 25 is equals to 29. So therefore we can say that x plus 4 whole square plus y minus 5 whole square is equals to 29 plus 25 plus 16, which will give us 70. Okay, so this is the completing square form of the equation of the circle, or you can say the standard form of the equation of the circle. So we are just making a comparison with the form of x minus a whole square plus y minus b whole square is equals to r square. So we can compare that 4 is equals to minus a, therefore a is minus 4. And minus 5 is basically equals to minus b, so b is equals to positive 5. Therefore, we can say that the center of the circle is minus 4 comma 5. Okay, because a comma b is the center of the circle and r is the radius. And since r square is equal to 70, so r square is equal to 70 and r is equal to under root of 70 units. Okay, we want to find the exact value of the radius. So this is basically the collective working of part A. All right, part A, part 1 and 2 both. After this, we have some information that the circle C2 has equation x minus 5 whole square plus y plus 8 whole square is equal to 52. Okay, and we need to prove that the circles C1 and C2, they are not intersecting and they cannot touch. So we need to show that these two circles neither touch nor intersect. Okay, So for that purpose, we need to show detailed reasoning over here. Okay. So basically, what's the thing is that, apart from the requirement of the question, I will also explain you other possible cases which the examiner can ask in the same way. Okay. So for that purpose, I will give some detailed explanation over here. So first thing I did, I made a sketch of whatever the information we have right now from the information which is given to us in the question. Okay, and so far whatever we have obtained in the working of part A. So far we have obtained from the working of part A that the center of the circle C1 is minus 4 comma 5. Okay, as we can see over here. And since r square is equal to 70, so radius is under root of 70. So just evaluate the value of under root 70. This is basically 8.37 something. So if you just put under root 70 in your calculator, you will get 8.37, meaning the radius of the circle C1 is 8.37, correct to 3SF. Okay. And then we have another circle which is C2. It has the equation x minus 5 whole square plus y plus 8 whole square is equals to 52, which means that 5 comma minus 8 is basically the center of circle C2. And since r square is 52, so radius is under root 52 units. Okay, so we just need to show that they do not intersect. I've just made a sketch over here. There was no requirement of making a sketch, but sometimes making a sketch makes things easier for you. However, in this question, the sketch was not, needed at all in order to proceed with your working. I just want to explain things in more detail. So that's why I've just made a sketch over here. Okay, you can, perfectly attempt this question without sketching. Sometimes sketching helps you a lot. So either way, sketching is not the requirement of the question. Okay. So sketching is just for your ease. It's not, a compulsory part of your working, and you won't be getting any marks on making a sketch. However, it's just a part of the procedure of your solution. Okay, which makes things easier for you to comprehend. By the way, here we have made a sketch. Okay, and what we know is that these 2 points. So here we have a point which is minus 4 comma 5, which is the center of circle C1. And here we have another point which is 5 comma minus 8, which is the center of the circle C2. Okay, so if they are not intersecting at all, if these two circles do not intersect at all, so obviously, according to this sketch, you can see that the distance between the two centers will be greater than the sum of these two radius. This makes sense to you or not? Distance between these two centers would be a greater value, okay, as compared to the sum of two radius, because when you add the two radius, okay, if you just observe this sketch, if I pick up this radius under root 52 and I place it over here and I add both of them, so I'll get the sum of the two radius, isn't it? And this will be lower in length, this will be lower in value as compared to the distance between the two centers of the circle. And this would prove that the circles cannot intersect each other, okay, at all. So that's basically the whole scenario. So first of all, I'm going to find the distance between the two centers over here. Okay, so one center is minus 4 comma 5 and the other one is 5 comma minus 8. So I've just used a formula for the distance between these 2 points and I've obtained a value which is 15.81 units. Okay, and basically when I add the two radius, so basically you say that this is the sum of two radius, or you can say sum of radii, which is basically plural of the radius. Okay, multiple radius are added, multiple radius are added, so we can say sum of radii. So anyways, the sum of the two radius is under root 70 plus under root 52, which is 15.58 units. Okay, so we can say that 15.58 is below 15.81. You can say 15.81 is more than 15.58, or you can just say that 15.58 is less than 15.81, which means that the sum of radii is less than the distance between the two centers. So here we have established the fact that the sum of the radii is less than distance between the two centers. Therefore, circles C1 and C2, they don't touch, they don't intersect. Okay. According to the exact wording of the question, I have mentioned my answer over here. So this was the complete working for part B. However, I want to do justice with this question, and for that purpose, I have explained two other possible cases which can be asked. Okay. If you have a scenario that the sum of radii is equal to the distance between the two centers. Okay, so I've made a sketch over here. Okay, if radius 1 plus radius 2 is equal to the distance between the two centers, so we will say that circles will touch each other at one point. All right, this makes sense. And if the circles are intersecting each other at two distinct points, if the circles are intersecting each other at two distinct points, so in this case, the sum of the two radius, meaning the sum of radii r1 plus r2 will be greater than the distance between the two centers. In this case, we are going to say that the circles will intersect each other at two distinct points. Okay, so basically the distance between the two centers is having this much length. But if I add the two radius, so R1 is ending over here, is starting over here and ending over here, and R2 is placed, let's say, somewhere over here. So when these two are added, they will give you a higher value as compared to the distance between the two centers. This makes sense. So if you are able to prove this thing that the sum of the two radius is greater than the distance between the two centers, this essentially means that the circles will intersect each other at two distinct points. Okay, so this was basically some extra explanation over here regarding this. So these two possible cases can also be asked in the same way. All right. So I hope this thing is clear. So now one more thing which I want to also discuss is an alternative approach to solve this part B. Okay, in order to do justice with this question. Okay, in the class, I did not have enough time to, discuss the alternative approach. So I'm going to do the working here from scratch and record this. Okay, so I left a blank page over here. So basically, the alternative approach to attempt this part B is that, you have the equation of circle C2 and you have the equation of circle C1 as well. Okay, now what you can do over here is that basically when equation of two circles are being equated with each other, okay, meaning if you want to find the points of intersection between the two circles, okay, so let's say we have a case something like this, that this one is C1 circle and let's say this one is C2 circle. So basically when you have two equations and you solve them simultaneously, you solve the two equations simultaneously, you equate two equations of the circle with each other. So you know what would happen? This x square and x square over here will get cancelled out. This y square and a y square over here will get cancelled out. And in the end, you will be left with a linear equation in terms of x and y. Okay, that linear equation is basically the equation of this line, which is a chord. Okay, basically the line which is intersecting the two circles, both of the circles at two distinct points. So the line which is connecting these 2 points, actually, you will obtain that equation. Okay, so this is basically the straight line which you are going to, obtain over here. All right. If the two circles are intersecting each other at two distinct points. Okay, so this essentially means that, for example, let's say this is circle C1, this is C2, and this is a line L. This essentially means that, when you substitute the equation of the line L either in the equation of circle C1 or the equation of circle C2. Okay, so you would be able to produce a quadratic equation in the form of ax square plus bx plus c is equal to 0. And in the case where the circles are intersecting each other at two distinct points, so in that case, the equation which you obtained, ax square plus bx plus c is equal to 0, by substituting the equation of the line L either into the equation of circle C1 or circle C2. So the nature of the roots of this quadratic equation would be, real and distinct, because there are 2 points of intersection over here. And this is basically the line L which is connecting these 2 points of intersection. Okay, so in that case, b square minus 4ac will be positive. Okay, in the case when two circles are intersecting each other at two distinct points. However, if the two circles are not intersecting each other at all, means they don't intersect each other or they don't meet at one point, what would happen in that case? Let's say if this is circle C1, okay, this is circle C1 and this is circle C2. So in that case, the equation of the line L which you are going to obtain by equating the equation of circle C1 with the equation of circle C2, so that would be basically this line. Okay, because if the two circles were intersecting each other, this would be the line of chord. Okay, but let's say in the original case of the question, in this particular case of the question, this line L would look something like this. Now you can substitute the equation of this line L either into the equation of circle C1 or circle C2, and then you would be able to produce a quadratic equation in the form ax square plus bx plus c is equal to 0. And in that equation, you are going to say that the nature of the roots is that they are not real, meaning b square minus 4ac would be negative. All right. And let's say if the circles meet each other at one point, you know, let's say this is circle C1 and we have C2, which will just touch the circle at a point, meaning C1 and C2, they just meet at one point like this. Okay, so in that case, the line L would look something like this. And when you pick up this line L and substitute this into the equation of circle C1 or circle C2, you would be able to produce a quadratic equation in the form of ax square plus bx plus c is equal to 0. And in that case, the nature of the roots will be that they are real and equal, meaning b square minus 4ac will be equal to 0. All right. So in this case, when two circles are intersecting each other at two distinct points, okay, in this case, we are going to say that b square minus 4ac will be positive. In this case, we are going to say that b square minus 4ac is equal to 0. In this case, we are going to say that b square minus 4ac is less than 0. All right, so this is basically the whole alternative approach which I wanted to discuss over here. Okay, so I'm just going to do the working on this same page. I am going to erase this complete thing. Okay, you can take a screenshot if you want. All right, I'm just going to erase this and make a space over here. All right, so basically, the equation of circle C1 is x square plus y square plus 8x minus 10y minus 29 is equal to 0. And now I'm going to expand the equation of circle C2 as well. Okay, so this turns out to be x square minus 2 times x times 5. Okay, and then plus 5 square and then plus y square plus 2 times y times 8 So 16y and then plus 8 square and then minus 52, and this whole thing is equal to 0. So x square minus 10x plus y square plus 16y plus 37 is equal to 0. So you might be wondering, how can I equate both of these equations? So basically, a basic idea is that 0 is equal to 0. So this means that x square plus y square plus 8x minus 10y minus 29 is equals to x square minus 10x plus y square plus 16y plus 37. Okay, and then you can see that this x square and x square gets cancelled out, y square and y square gets cancelled out, and therefore you would be able to obtain a linear equation. Okay, and that line is basically the line of chord if the circles were intersecting each other. Okay, so this is basically the whole idea. So I can say that 8x minus 10y minus 29 plus 10x minus 16y minus 37 is equal to 0. So 18x minus 26y and then minus 29 minus 37, this turns out to be minus 66, and this whole thing is equal to 0. So I can say that y is equals to 18x minus 66 completely divided by 26. So now what I'm going to do is I'm going to substitute this equation of the line into the equation of circle C1 or equation of circle C2. I can use any of them. Okay, so I will just substitute it in C1. You can substitute it in C2. Okay, so x square plus 18x minus 66 completely divided by 26 whole squared, and then plus 8x minus 10 times 18x minus 66 upon 26, and then minus 29, and this whole thing is equal to 0. Alright, so far we have obtained this much, and now I'm going to do the expansion and simplification. So x square plus what? 18 is squared, so this is 324, so 324 x square, and then 2 times 18 times 66, this is minus 2376. Okay, minus 2376x, and then plus 66 is squared, so this is 4356 completely divided by, I mean these three terms are being completely divided by 26 squared, meaning 676, and then plus 8x minus 180x plus 660 divided by 26 and then minus 29, and this whole thing is equal to 0. So far we have achieved this much. So now I'm going to simplify the terms. So the term in x square 1 plus 324 over 676, this will give me 250 over 169 multiplied by x square. And then I'm going to simplify the terms in x. So minus 2376x over 676 plus 8x minus 180x over 26. So this gives us minus 412 divided by 169. This is the term in x. Okay, so minus 412 over 169 into x. And then we are going to simplify the constant terms. So 4356 over 676 plus 660 over 26 minus 29. So this gives us 478 478 over 169, and this whole thing is equal to 0. And now I can basically multiply 169 on both sides. So 250x square minus 412x plus 478 is equal to 0. This is basically the quadratic equation which we have obtained by substituting the linear equation into the equation of circle C1. And now we are just going to show that the nature of the roots of this quadratic equation is not real. Okay, we just need to show that the value of b square minus 4ac is negative. Okay, so minus 412 whole squared minus 4 times 250 times 478. So this value is minus 308 minus 308256, which is basically less than 0. So here we have established that, the nature of the roots is that roots are not real. Okay, roots are not real. Since b square minus 4ac is less than 0, and therefore we have proved that, we have proved the fact that the circles C1 and C2, they don't touch and they don't intersect. All right, and here we are going to write the proof in a statement, in a brief statement. Therefore, the circles C1 and C2, they don't touch, they don't intersect. So it's always good to use the exact wording of the question in order to prove something. So in this way, we have attempted this question. This was basically an alternative approach. All right. Since I wanted to do a complete justice with this question and I did not have enough time to explain this, you know, method in the class, so I solved it from scratch on this page because in the class I wanted to discuss more questions, more important questions. So this was basically the alternative approach for part B. All right. So in this video, I have discussed only one question, which is June 2024, question number 7. Inshallah, I'll be uploading more videos. So stay tuned to my channel. Thanks for watching. Assalamu alaikum.